Discovery Education and NASA present NASA at 50. A look back at NASA's 50 years of innovation and achievement. 1998. NASA begins work to preserve the original copies of the Declaration of Independence, the Constitution, and the Bill of Rights.
In the late 1700s, three of the world's most important documents were written here in the United States. Now called the Charters of Freedom, the Declaration of Independence, the Constitution, and the Bill of Rights were conceived and written by early Americans who believed that tyrannical rule and oppression should be replaced by individual liberties and freedom. Until the mid-20th century, these documents were proudly displayed for the general public. But the years of inadequate preservation left them a bit faded and brittle. This all changed in 1951 when the documents were placed in specially adapted encasements which were designed to slow down the deterioration process. These glass encasements were filled with inert helium, which would protect the documents from the harmful chemically corrosive effects of air, keeping them safe for generations to come. But in the late 1990s, conservators began noticing that the documents were, in fact, still showing signs of deterioration. Mysterious small white spots were appearing inside the encasements and on the documents. To help determine the cause of the deterioration and how to fix the problem, the National Archives asked researchers at NASA to perform a series of tests on the atmosphere inside the encasements. I spoke with Dr. Joel Levine at NASA Langley Research Center to find out more.
In 1951, the National Bureau of Standards, which is now NIST, the National Institute of Standards and Technology, was asked by the National Archives to preserve these very important documents, the Declaration of Independence, the U.S. Constitution, and the Bill of Rights. It became apparent several years prior to 1998 that some mysterious white spots appeared in all encasements, and over time, over several years, they increased in number. The National Archive conservators wanted to know if we had technology that could determine the chemical composition of the encasements non-invasively. Non-invasively means without extracting air. We didn't want to touch the air, we didn't want to touch the encasement. We wanted to come up with some technique that could tell us the answer without disturbing the contents of the encasement, both the documents and the atmosphere. After considerable discussion, we decided we should use a technique called laser spectroscopy. What the laser did is provide energy at the very wavelength that water vapor absorbs, and as we looked at the absorption, we could determine what the background gas was. We're interested in not the document, but the atmosphere in the encasement that's protecting the document. What we found is that the gas that was sealed 50 years ago was still there.
When the laser studies were done, NASA researchers conclusively determined that helium in the encasements had not leaked out. This determination only increased concerns over the origin of the mysterious white spots. Most conservators believed that chemically corrosive air had leaked into the encasements, causing the damage. With this belief dispelled, the puzzle only intensified.
So in some instance, we actually went back to step one because we still had the problem. The problem is what is responsible for these white spots. We eliminated air as a corrosive agent. And the next thing the National Archives asked us is could we tell them non-invasively how much water vapor was in the encasement.
Because the documents were written on sheepskin, which requires a small amount of water vapor for stability, the relative humidity inside the encasements was originally set between 25 and 35%. To determine if the humidity levels had changed, the NASA researchers needed to measure the relative humidity inside the sealed encasement. The first technique considered involved placing the encasements in a freezer to cause the condensation of gaseous water vapor to liquid water droplets. This idea was rejected due to the distinct possibility that the documents inside could be damaged by the condensed water. It was later decided that the humidity could be checked by using a very inexpensive device called a thermal electrocooler. This device would sample only a small area of the encasements, keeping the documents inside safe.
I called up the archives and I said, we just have to freeze a small part of it at the edge where there is no document, no ink, and we can solve your problem.
When the humidity levels were checked, it was found that the levels inside the encasement were 60 to 65%, twice the expected relative humidity. This is because when the documents were originally sealed in 1951, the relative humidity in Washington, D.C. was very high. The backing paper that the documents were laid upon had actually soaked up water vapor like a sponge. Once the documents were encased, the water vapor inside the backing paper could not escape, so it remained in the encasement's atmosphere, causing the humidity to rise.
The white spots were basic or alkaline chemicals that were pulled out of the glass because of the presence of high levels of water vapor. And now, when the National Archives opens with its new encasements, we are all sure that the documents will be stable for many centuries. And in some small part, NASA scientists and NASA technology help preserve these documents for many generations to come.
Did you know? Since 2003, the Charters of Freedom have been displayed in new encasements filled with argon. Argon atoms are larger than helium atoms, making them less likely to diffuse out of the encasement. To learn more about science, technology, engineering, and mathematics, visit www.discoveryeducation.com and www.nasa.gov.